And if you don't remember anything, I would say to go home and go back over it. Okay, so we know that it needs to be in y equals, and we need to have a 1 in front of our x. We agree? This one's in y equals, and it has a 1 in front of the x, so I know that I can start. Okay, is there anything with the x? Is there anything in the bracket with the x? No, so nothing is going to affect the x's. So I know immediately that my mapping, my xy, is going to be x something. I know my x is going to stay the same because absolutely nothing is happening to my x's, correct? Now, what order do we have to list our transformations in? SRT. Stretch, reflect, translate. So, what kind of stretches do we have?
Vertical stretch.
We have a vertical stretch. By a factor of 1/2, yeah. About the x-axis. Now remember, the vertical ones always stay the same, the horizontal are the ones that flip, right? Do I have a reflection in the x-axis? No, because there's no negative in front of that half, correct? I don't have a reflection in the y because there's nothing with the x. And so the reflections, there's none. Translations? What's the -2? Well, nope. It's not with the x. It's a vertical translation. Yeah.
Make her really happy. I thought it would make her really happy, not puzzled. Are you really happy or are you puzzled?
No, I'm good. I thought like I was like gonna be like really happy with the one that's lost.
Oh shoot, I thought that's what that was.
No. But thank you.
Sorry, I thought I was bringing really good luck.
No, this is good. Just this is like half as good as the other one.
Okay, I'll try again tomorrow.
Okay, vertical translation. 2 units. Where?
Down.
Down. Okay. What's my mapping? So whatever numbers I use in my words, I'm going to use those exact same numbers in my mapping. We agree? Yeah, so we're going to multiply our y's by 1/2. And then we're going to subtract 2. Okay, I want you to try B and C. What's the catch with C? There's a -2 in front of the x. You need to take it out of the x and the 10. Right? Before you, so your horizontal translation's not wrong. So try both B and C out. I want words and mapping. Alright. So this one, there's a negative and a 3. So what kind of stretch do we have? Yeah, vertical stretch. It has to be written properly by a factor of 3. About the x-axis. Do I have a horizontal stretch?
No.
No, there's nothing in front of the x, so I don't have a horizontal stretch. I have a
Reflection in the x-axis.
reflection in the x-axis because there's a negative in front. And a horizontal translation is with the x.
So I think it's 5.
Other way.
Oh.
Horizontal translation, 5 units right. And like this is a +0 back. This I would say makes a y, so these outside ones affect the y, and then this affects the x. So if you go to do mapping, the only thing that's going to affect the x is what's in that bracket, correct? So we're going to have xy becomes x. Now I need to move it 5 to the right, so I'm going to add 5. Then my y, I'm going to multiply by -3. So y, words, mapping, equation, all the same. X's, do some switching. So for C, I have to take the -2 out. So I get F bracket -2 bracket X. Now 10 divided by -2 is -5. Now it's still with the X. Even though it's not exactly right with the X, it still is because I can distribute it into it, right? It has a bracket, it's right there, it's with the X. It doesn't become a vertical stretch now just because I took it out. It's still horizontal. So there is a vertical stretch because there's something in front. What's the vertical stretch? By a factor of 4. A 4 about the what? About the x-axis. Is there a horizontal stretch? Yeah, because there's a 2 in front now. But it's actually a horizontal stretch by a factor of 1/2. Because it's 2 over 1, it always flips. Horizontal stretch by a factor of 1/2 about the y-axis. Are there any reflections? Yep, there's one here. It's with the x, right? So it's a reflection in the y-axis. If it's with the x, it's always reflection in the y-axis. And then I have one last thing. A horizontal translation, 5 right, just like the last one, right? So I go do mapping, my x, y. What's in here affects my x. Anything that's not in there affects my y. So my x is going to be multiplied by not -2, it's going to be multiplied by -1/2. X, and then we're going to add 5. We're going 5 right. And then my y is being multiplied by 4y. Try example 2. Removing the point M3N. What's our first step before we do anything? Make sure it's in y equals and make sure there's a positive 1 in front of the x. Is that currently the truth? No. So most people will spot if it's a number, most people will do well. If it's just a -1, most people will get the horizontal translation wrong and forget to take the -1 out. So we're going to get y equals to f -1 x, and then 3 divide by -1 is -3. So it's actually 3 right, not 3 left, which people will give me the answer to, and it will be there. That answer will be there, the wrong one. Okay? So we have a vertical stretch. By a factor of 2 about the x-axis. We have no horizontal stretch because there's no number there. We don't have a reflection in the x, but we do have a reflection in the y-axis because it's with the x. So we have to stretch, reflect, translate, cert. Then our translations, we can state horizontal first, then vertical, or vertical then horizontal. It doesn't matter, but it has to go stretches, either order. Reflections, either order. Translations, either order. So our translations, we have a horizontal translation. Three units right. And a vertical translation. One unit down. Then we do our mapping. Whatever's in here affects our x for mapping. Whatever's on the outside affects our y's. So we're going to get xy becomes negative x and then plus 3, and then 2y minus 1. And they want us to move the point m and 3n. So we're going to get negative m plus 3, and then 2 times 3n minus 1. So we get negative n plus 3 and 6n minus 1. Then we're going to flip over. Okay, this one is actually words that you have to put into the equation. So I want you to do that, write the new equation that would be transformed. And then this one I just want you to state the transformations that happen. You don't need to sketch anything. I just want you to go from here to here what transformations happen. So example 3 and 4. Well, let's try this one. So it says it's stretched vertically by a factor of 3. So we're going to get y equals, now what you always have to do is apply your stretches, reflections, and then your translations. So in this case, because it's just a basic x cubed, it's not going to matter. But I'm going to show you if I add something else to it, how it does change it. Okay? So we have y equals x cubed. It's vertically by a factor of 3, so it's going to be 3 reflected in the y-axis. So it's going to be negative x cubed. Because if it's reflected in the y-axis with the x. Translated to left. So if I want to go to left, I still need to have a positive 1 in front, right? So in order to have a positive 1, I need to have a bracket. So 2 left, so I'm going to go plus 2. And then 4 up, plus 4. So you could have also written it as y equals 3, negative x minus 2, plus 4. So you could take the negative and distribute it through. The next one, we have to state the transformations. So here we would have a vertical stretch. By a factor of a half. About the x-axis. And then we have a horizontal translation. Four units left. And a vertical translation. Five units down. As a mapping, this would be affecting the x and this would affect the y's. So we'd have xy becomes x what for? We need to move 4 left, so x minus 4, yep. And then 1/2 y minus 5. Then we're going to flip over. Let's get free. Okay, I want you to do 6a and b, and then we're moving on to inverses. So here you have the function y equals f of x. I want what it's going to be once you add the transformations. So try it out. We're going from words, or even if we went from mapping, and we're going back into the equation. So the horizontals are always going to flip. We agree? We go from words, mapping, back into equation. So we're going to go y equals, we have a horizontal stretch by a factor of a quarter. So I am going to get 4x. And a vertical translation 5 down. Minus 5. So remember, words and mapping are in a heart together. Their numbers are always the same. But when we go from words or mapping into equation, the horizontals will flip. And equation to words and mapping, horizontals will flip. Okay? Here we have vertical stretch by a factor of 3/5. And a reflection in the y-axis. So that's with the x. And a horizontal translation 2 left. So I'm going to add 2. Now remember, you always have to have the negative or the stretch out here, and there has to be a 1 here in order to put your horizontal translation correct, right? Once again, you could distribute it through, and they could give the answer 3/5 f negative x minus 2. Now remember, I handed out that hand-in right before the break or whatever? After we do inverses today, that can be handed in. That will be able to be completed, and I would like it by Wednesday. Possibly Thursday. I might take it by Friday. We'll see. Maybe Friday. Because I want you to finish it and do well on it. Because we're not writing the test on transformations. We're going to do transformations with the next unit as well. So I can keep asking you questions over and over and over daily and daily and daily so you stop making mistakes and flipping them. Or being like, I think that's scary. That maybe scary in this unit. You have to know like exactly what you do. Okay? So I'm going to make that hand-in due Friday. That gives you a lot of days to figure out when you should do it. I would not leave it till Thursday night. That would be a very bad decision. You will not finish it and you will do crappy on it. Okay? Who are you?
No.
I'm not inviting you to this class. Okay. Inverses. So inverses is also part of the transformation unit, but it's because we transform graphs by finding the inverse of something, but it's not like it adds to this. It's not like you have to remember like another something that adds to the mapping and the transformations. It's totally a separate entity by itself. Okay? So here we have, if they want to ask you for the inverse, they could ask you to find the inverse by giving you this. They could say y equals f negative 1x. They could say, or determine x equals f of y. Or they could say it's reflected in the line y equals x. Or they could say reflected in the identity line. This is not often done, but they could do it. Because the identity line is y equals x. And that would be them, or they could just say determine the inverse, which literally is direct, like find the inverse, right? But they could say it in any of those ways, and they're asking you to find the inverse. So, we're going to go down to B first. I know it seems weird, but we're going to come back up to A in a second. So I want you to graph y equals x minus 5 squared on your calculator. So go into your calculator and go x minus 5 squared. X minus 5 squared, and then you're going to go zoom 6 because you might have a crazy polynomial window right now. So go x minus 5 squared and then go zoom 6.
Nothing shows up.
You don't have an x then. Do you have x minus 5 or do you have x negative 5?
X minus 5.
Squared?
Yes,
Well, it needs to be like that in brackets.
but it's me. Put it in brackets though.
Yeah, if not, you're just squaring the 5. Because if you just put it squared, it doesn't know you want to square the whole thing. Okay, so we press graph, and what actually happened is this the graph that moved 5 to the right, correct? It took your normal parabola at x squared, and it moved it 5 to the right. Okay? So we know that it's at 5, 0. So I'm going to put that. One of the coordinates is at 5, 0. I'm going to make my x scale be 1, but my y scale be 2. Or I'm going to run out of room real quick. So each of my y's are going to be worth 2, and my x are going to be worth 1. And I know 5, 0 is where I start. That's where the vertex is. How do I get more points? How do you get points on your graph calculator? I see people doing it, so I know they know how. Second, what? Nope. How do you get points? Coordinates. Second, yeah, table. How do you get the table? How do you get the table, Ryder? Second graph. So you go second graph, and you have to put down your marker because it doesn't look like you're holding it. So you have to go second graph, and why do we do second graph? Whenever we press second, what are we looking for? The word above, right? So it's the word above graph, which is actually table. So that's why we're pressing second graph, because the word above graph is table, right? Okay, now what I want to do is I want to locate where the heck my vertex is and put that in the middle of my table. All right, there we go. So 5, 0, and then I'm going to put 4, 1, 3, 4, 2, 9, and I'm going to plot all the other ones on the other side, and then I'll have a parabola, correct? So I always put my vertex in the middle. So does my vertex always end up on this table? No, because the only x values on this table are whole numbers, correct? If my vertex is a decimal, it's not ending up on here. So you might actually have to find your vertex another way. How can we find our vertex another way? If I go second calc, which is where we're going to go for life and most of the options, people are like, I don't know what to do because there's no word vertex, correct? But our minimum or our maximum are just a fancy way of asking for a vertex. And because this one is concave up, we'd actually find the minimum. So we're going to pick 3 because it's the lowest we can go, and then it wants left bound. So I would want to be on the left side of it, which I currently am already on it. That's okay. So left bound, enter, then right bound. This is all from last year. Enter, enter. So it's at 5, and what's e to the negative 11? 0. So it's at 5, 0, which proved we were right. So then we need points on the other sides of it. So we have 4, 1, 6, 1. Remember, I made my y scale be worth 2. So 4, 1 is actually here, 6, 1 is here. And then it's going to be at 7, 4. And then 3, 4. And then 8 and 9. And then 2 and 9. So I just used values off my table, right? And plotted them, remembering that my y scale is 2. Now, if I want to graph an inverse, the only way you actually have to find the equation of an inverse is if it says determine the equation of an inverse. Other than that, I can answer any questions about inverses off of my graph. So, let's first talk about this graph before I find the inverse of it. What's the domain of it? Anyone know? Yep. So my domain, so this is going to be of the original, y equals f of x. My domain is going to be x such that x is an element of the reals. Beside here, we're going to do the inverse after. So we're going to have like a 2 spot here. What's the range of this graph? y is greater than or equal to 0. We'll do set notation later. What's my x-intercept? What's my y-intercept? How do we find it? Set x equal to 0. So our equation is y equals 0 minus 5 squared. So it's going to equal 25. We agree? Okay, the cool thing about inverses is that inverses reflect on the line y equals x. So I'm going to sketch that in here in like a yellow. So the line y equals x is when all your y's equal x. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, negative 1, negative 1, negative 2, negative 2, etc., etc. I'm going to put a dashed line through it because that's my reflecting line. So this is the line y equals x. Not the easiest to see. That's just the line y equals x. So that's the line that we're going to reflect on. Basically 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, etc. Right? So that's going to be our mirror. Until now, the only reflections we've had are on the x-axis or y-axis. This is going to be reflected on the line y equals x. So the only thing that actually stays the same when you reflect on just the x-axis is anything on the x-axis. Remember, it remains invariant, right? And then when you reflect on the y, the only thing that stays the same is anything on the y-axis. It remains invariant. Do you agree? So when you're reflecting on the line y equals x, the only thing that remains invariant is anything that's on the line y equals x. So this graph actually has two invariant points between it and its inverse. I haven't even drawn its inverse. But I know it has two invariants because it crosses through here and it's going to cross through here, correct? So those are my two invariant points. Did I even find the inverse yet? No. Do I need to find the inverse to say that those are invariant? No. Because that's the reflecting line. They're going to reflect on there and they're going to stay there. So the red dots are the invariant points. Now, what happens when you have inverses, your mapping is this. xy becomes yx. When something is an inverse of itself, the x's and the y's switch. So why would anything on the line y equals x remain invariant, which means it doesn't change when I do the inverse of it? When they flip, they're the same. Anything on that line is like 2, 2. When I flip it, it's 2, 2. And 7, 7 is 7, 7. And anything else, even on not right, like this one's not going right through it, even if that's happening, it would be like 2.7 and 2.7. If I flip them, it's 2.7 and 2.7, right? Yeah.
But the y scale is 2.
That's so disappointing. No! You just ruined my life, Austin. You ruined my life. There's still two invariants. They're not there. Savenya, thank you for erasable marker. You know, when you're right, but that still sucks for me. We're gonna. Oh, there we go. Oops, on my behalf. I'm looking at you like it's your fault, but it's. This is the issue. Oh, this is the issue with changing your scale. Is remembering you changed it. I changed it in period 2 as well with their quadratics, and half the time I kept forgetting it's changed. So I'm really good at it. Okay, so 0, 0, 1, 1, 2, 2, 3, 3. Much steeper line. Still two invariants. Not at all where they were left. Brain is halting. Okay. Now we still have 2. They're just not at all where they were before. Okay. So how can I sketch the graph really easily? How can I sketch the graph easy? I'm so glad that Mr. Lyle has his hockey stick out. That noises. Just flip the points. That's it. Is there a lot of brain matter needed? No. Start from the left, move to the right, change the points. Right? So, do you want to know how many people get these wrong because they literally just flip the points wrong or count wrong? It happens way too much. So double check yourself. Like, if the graph is a parabola, and then when you draw it, it doesn't look sideways parabola, it looks like a snake of some sort, it needs to like reflect itself in the line. So we're starting here with 2 and 2, 4, 6, 8, 9. So now I need to go to 9 and 2. I'm going to use a different color. So now I need to go 9 and 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 2. Boom. So 2, 9 became 9, 2. Then I go to the next point, sketch it, connect. Remember how I told you sketch, connect, sketch, connect, sketch, connect, or some crazy things happen. Now this one is at 1, 2, 3, and 4. Remember your Y scale is 2. That's me reminding myself. And it's 4, 3. 1, 2, 3, 4, 3. Then we have 4, 1. It's going to be 1, 4. 1, 4. 1. I didn't, look guys, look what I did. I scared myself. You're just working with it. That doesn't exist. I'm going to pray to the Y scale 2 gods to help me out here. The squiggly green one doesn't exist. Okay. Then we have 5, 0. It's going to be 0, 5. Then we're going to go that way. Now we have 6, 1. It's going to be 1, 6. And then we have 7, 4. It's going to be 4, 7. And then we have 8, 9. Maybe 9, 8. Now these red dots should be perfect, but my sketching is a little bit off. But do you see how they're actually crossing through the same spot, which is on that yellow line? They are invariant there. Did I need to draw the new graph to get those invariants though? No, I need to draw the line y equals x, and I could just get the invariant points, right, without sketching the new one at all. Now, does it look like it's reflecting? This piece here, this blue piece, is reflecting with the end piece of the green, and then this arm here is reflecting with this arm here. This arm here is reflecting with that arm there. And then that squiggly line that shouldn't be there is reflecting with nothing. It shouldn't be there, but I am too lazy to take it. Although it's bothering me. I wonder if I can get a small enough eraser. Yes, it makes sense. Didn't happen unless you actually watch the podcast. No one does. Okay, good talk. So, the sideways green one is the inverse. Do you see that? Does everyone understand what I did? I just took the x, y's, made them y-axis. We agree? Okay. So we're going to look at the green one now, and we're going to state its domain. The green one's domain. Where's my x start at? for the green one. 0 and greater, right? So my domain is x such that x is greater than or equal to 0, XER. Do you notice something similar with the other side? It's the same as the range, right? Because what am I doing when I'm finding the inverse? I'm just swapping the x's and y's. So this y is going to become a x. So did I have to draw the original graph or the new graph to get the domain of the new? No, I just needed to get the range of the original, and that would be the domain of my inverse. So the domain of my original is going to be the range of my inverse. If you look here, this is going on for life up and on for life down. So my range is going to be YER. Because my x's will become y's. My y's will become x's. So if I have the domain in the range of the original, I actually have the domain in the range of the inverse as well, because I just switched the x's and y's. Okay? So what do you think is going to happen to the x-intercept of the original? It's going to switch, and it's going to become the y-intercept, because my xy is going to become my yx. So my x-intercept is going to become my y-intercept at 0, 5, which it is. And my y-intercept is going to become my x-intercept. So did I actually have to find the inverse at all? Unless they asked me to graph the inverse? Yeah, I don't. I can give the x-intercepts from the y from the x, the domain from the range, and the range from the domain. Because my x's and y's just flip. So I have to graph an inverse when it says graph the inverse. Okay? We already marked the invariant points in red twice because I screwed up the first time. Awesome. Go up to A. So the place where people struggle the most with inverses is actually writing the equation of the inverse. And it's due to solving errors. So if I want to find an inverse, what am I just doing? I'm swapping my x's and y's. My y's becoming x's, my x becoming y's. Do you agree? So when you're finding the equation of an inverse, step 1 is to make swap your x's and y's. Make your y be x and your x be y. Then step 2 is solve for y. Or isolate y. That's it. So our original is technically y equals x minus 5 squared. So what are we going to do first? Write it as so this y is going to become x equals, and the x is going to become y minus 5 squared. Now that's actually the inverse equation. Problem is, that'll never be the multiple choice option. Well, not never. It's rarely. Once it was, and then people will solve too far. So now I need to get y by itself. How do I get y by itself? Square root. And when I square root, I have to remember to do what? You were taught this before. I know you were. What has to go in front of a square root sign? No, in front. Whenever you take the square root of something, you take the plus or minus. And we need plus or minus, or we're only going to get one arm. Do you see how there's two arms on this? No, it's not.
Only x.
No. So plus or minus root x equals y minus 5. And then what do we have to do? Just add 5. So we're going to get y equals f negative 1x, if we want, equals 5 plus or minus root x. Now, we want to try this out in our calculator and see. Okay? So in your calculator, you currently have y equals x minus 5 squared. We agree? Leave it there. Let's take that out. Now what I want you to do, in y2, you're going to put just x, and you're going to make the line thicker like I taught you how to do. So you're going to arrow to the left to make it thicker. So in y2, you're just going to go y equals x. Why would I make you put that on? Yeah, it's the identity line. So We have this in our original. In this one, we're going to put y equals x, and then you're going to go arrow over here and make it thicker. Hit enter, right? I have colors, so I can't do it, but you'll arrow over to the slash line and hit enter. I taught you that already. And then you press graph. I'm not even putting the inverse on right now. Can I find the invariant points without doing the inverse now? Can I find the invariant points without doing the inverse? Yeah. The invariant points are where that graph lines up with the line y equals x. We agree? So I don't even need to find the inverse. I could go second trace 5. Enter, enter, enter. And this one's at, weird, they're the same on the x and the y. Oh, they have to be, because that's how they switch, right? So this inverse is 3.2087 and 3.2087, da, 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 right? Then we have to find our other one, second trace 5. Second trace 5. Enter, enter, enter. 7.79128878, and then the same thing for y, right? So do our invariant points have to be like 3377, or could they be decimals? They can be decimals. Okay? People forget about the decimal options, and they'll tell me there's none. I'm like, well, actually, there's 2. So now let's put in our other one. Our other one we have to put in 2 steps, because there is no plus or minus button. So you're going to have to go, the equation is 5 plus root x and 5 minus root x. You have to put it in separate. So 5 plus root x, and then 5 minus root x. So you have to put them in separate. You can't put them in together. See some random person without shoes, and I'll be like, I know what you did, sir. Okay. Now are they in the invariant points, same spot? So, bless you. In order to find invariance, you can just take the original and do the line y equals x, find out where they intersect, or you can put the 2 graphs and find out where they intersect, right? It should be the same thing, so you should be able to double check your work. All right. So, here's example 2. Here's a graph of f of x. I want you to sketch the graph of f negative 1x. Go.
No.
Yeah.
We're sinking.
We're sinking? We'll bring you back. Okay. So I would use at least 2 points on the arm. So here, here, and here. At least if you have these 3, you'll be golden. So we're at 1, 2, 3, negative 4, 0. It's going to become 0, negative 4. Then I go to the next one. I don't like make gaps because then it gets all crazy. I'm going to go to my next one, which is at negative 1 and 4. So it's going to become 4 and negative 1. I'm going to put a line. And then I have 1, 0. It's going to become 0, 1. How many invariant points does this graph have?
Maybe 4. Depending on how far. Well, there is 4, but with those lines, there's 3.
There is a certain UP class.
There's 1. Invariant
Never
means
mind.
does not change. It doesn't mean we'll come back. Okay? I don't know why my voice changed. But anyways. Invariant means it did not change. Where do the invariant points lie on the inverse graph? On the line? Y equals x.
It's not even 1.
No, I just, the people kept answering and giving me more and more.
It's 60 mentality.
Okay. What would be better on a test for these ones would be to have end bullets so that you know it stops and you can't keep going. Okay. So, what I care about the most here is, actually, when I ask a question like this on the test all the time, people will give me like every place they cross. Remember, every place they cross doesn't mean it's invariant, correct? That means that a point just became moved and moved onto that point again. That's fine, but it's still not invariant. Invariant means did not move, always there, always will be. Okay, so if I take my f of x graph, what's my domain? What's the domain of my f of x graph?
Thanks, element real.
Yeah. So I'm going to go negative infinity to infinity. And my range?
Y is less than or equal to 4.
Yeah, so it's less than or equal to 4. So if I write that as a number line, here would be my 4, here would be equal to, here would be less than. This is negative infinity, right? So it'd be negative infinity to 4 square bracket. What are my x-intercepts? They're at negative 4, 0, and 1, 0. And my y-intercept is 0, 2. Okay, if I do f negative 1x, I'm not even going to look at the graph at all. I'm just going to look at these. So if my domain is negative infinity to infinity, what's that going to be on my f inverse? My domain becomes my range, and my range becomes my, because your x's and y's swap. So, if my domain is negative infinity to infinity, my range is going to be negative infinity to infinity. Which makes sense, because this is going down forever and up forever. Right? Couple one? My range is negative infinity to 4, so my domain is going to be negative infinity to 4. Square bracket. My x-intercepts are negative 4, 0, 1, 0. What are they going to be on my new one? What are my x-intercepts going to be on my new one?
2, 0.
Yeah, but what my x-intercepts going to become on this one?
Only 1.
My y-intercept. And my x-intercept is going to become from my... Okay, I'm going to give you some questions. We have one little thing left to do, which we'll do at the beginning of class tomorrow. It's restricting the domain of an original, so the inverse is a function. It's in your curriculum. And then we're also moving on to radicals and rationals and other functions.
Yeah.
Do you know you signed up for 30-1?
Yeah.
Okay, just checking. I didn't know if you knew. Okay, so your homework is page 51. Page 51. Number 2. And then five ACE 6. And 9 minus the graphing. So 9 says determine the equation of the inverse, which I want you to do. Then it says graph them. I do not want you to do that. Then it says determine the domain and range, which I want you to do. So for number 9, I do not want you to graph. If you don't listen to me right now and you graph them, that's on you. That's good.
So there was no
Payback.
questions between 2 and 5 that we had to do?
Nope, 2, 5 ACE, 6, and 9 no graphing.
It's like another